Okay, so today we're going to look at solving a differential equation. We talked about differential equations before. Differential equations are equations with a derivative, okay? When we have to solve a differential equation, that means obtaining a function without derivatives or differentials. We integrate to solve a differential equation. Okay, so this is what it means, and this is how we're going to do it. So, if you do struggle or need some help, make sure that you look for how to do it for separable differential equations. In other courses, they may not be separable, and there's other methods and means, and if you look online, you may end up trying to figure out something that's much harder than we actually have to do here. So for separable differential equations, okay, this is the ones we're going to solve. We're going to get all the x's and constants on one side, that's typically on the right-hand side, and all the y's on the other. That's typically on the left side. Multiply each side by dx. This is very similar to when we're solving our initial value problems. Integrate each side. If necessary, substitute initial values. Okay, so that's pretty much from the lesson we heard of the phrase differential equations to solve for c. So it is important that we solve for c when we can. Okay, so it depends on the problem that we have to do. So let's take a look at our example and ask me any questions if you need to. Let's go. Remember, if you didn't get that procedure down in your notebook, procedure is pretty important. You know what to do step by step. Make sure you kind of rewind the video because I'm already up to the example. All right, so let's go do our example. So basically when it says dy over dx is 2xy with g of 0 is equal to 3, that's the same as saying g of x is y. So the x value being 0 and the y value being 3. Okay, so this one we're going to be able to solve for c. Okay, so let's keep going. So we have dy over dx, and it equals 2xy. I'm going to divide both sides by y, and multiply both sides by dx. Or I can multiply both sides by 1 over y, and then multiply both sides by dx. It's essentially going to give us the same thing as this step. If you do it in one step or you do it in two, that's fine. Okay, so now we're up to the part where we can integrate. We're going to integrate both sides of our equation. And I'm going to put it over here because we know the constant can be pulled out of the integral. And let's keep going. So it's an indefinite integral, and with that we write plus c. I'm going to do that to both sides, and I'm going to give different subscripts here. Okay. Just as I had said before, it doesn't matter if the subscripts are there or not. Once we subtract this over to the other side, it's still a constant. Even if it's the same amount, it's still going to be a constant of 0. So we're just going to write plus c here. And to solve a log equation, we're going to raise each expression on the left side of the equation and the right side of our equation to the exponent for e, because it's one of our properties. If you have e to the ln of x, it equals x. ln and e, they're inverse functions, they undo each other. So you're going to end up with this expression right here. Now, speaking of maybe logs and exponentials, things we've worked in prior courses, we also worked with rules of exponents. So for rules of exponents, we could rewrite this expression. Okay, so let me know if you have any questions, if I'm going too fast, maybe with the antiderivatives or using our inverse of e to eliminate our logarithm. But now I'm going to talk about rewriting the expression on the right-hand side as e to the x squared times e to the c power. So now you may be looking at this, how did you do that? Well, if they have the same base, you add your exponents. So if you see addition in exponents, they had the same base, which is e, and each one of them was a separate exponent. So we're kind of reversing it. You need to know those rules backwards and forwards. Now we're kind of using it backwards. You may be wondering why. Well, e to the c, e is a number and c is a number. So let's say something easy. Let's say that's 3 squared, okay, instead of 2.718 is some constant. 3 squared is 9, okay. Let's say it's 2 cubed. All right, we'll reverse it. So that would be 8. Well, those numbers that we keep getting over here are constants. So we end up with this expression here, okay. This is called our general solution, but we need a particular one, okay? So we're going to work on that. So make sure you get down the general solution. We're going to work on a particular one because here we have absolute value. We're going to talk about that. Let me know if you have any questions. Okay, so you know about solving absolute value equations. There's case 1 and there's case 2, okay? There's where your absolute value is positive and when it is negative. Okay, it gives you the same result because our absolute value always gives us a positive result. Okay, so that's why there's 2 different cases. Well, we actually only need one of them. We actually just need case 1. And I'm showing you both cases just to make sure you understand. I didn't throw something out the window. Okay? So at this point, I want to plug in x equals 0 and y equals 3. And I'm going to do that for both. Okay? But before I do, let me just finish one side. So it would be helpful if I didn't write 3 twice. That's supposed to be 0. What am I doing here? So e to 0 power is 1. 1 times anything is c. So c is equal to 3. Hopefully I didn't lose you there. Let me write it the other way so you can clearly see that. cc. All right. So that means that y is equal to not ce to the x squared, but 3e to the x squared. Okay, you're done. So now what happened with case 2? Why is it negated? Well, here we go. So if we're to isolate y, we multiply both sides by -1 or we divide by -1. What happens when we negate c? Well, it's still a constant. So nothing much really happened. Okay, so that's why it's not needed. It becomes the same thing as we're working with in case 1. Let's say we didn't realize that at all, okay? And we proceed to start to work with this expression here, okay? Well, if we plug in 3 for y and 0 for x, and make sure this time you write 0. I don't know what happened to me the last time. When you go to solve, this is going to be negative c equals 3. So c equals -3. And then you plug that back into what we're working with, okay? So we're working with y equals a negative c. So we have a different value for c, but remember we had a different expression. So our expression still becomes the same exact thing we had in case 1. So once again, it's not needed. Okay? I'm going to box that off. So that's pretty much it. I just want to go over, so our general solution is with C in it. And then once we're able to plug in our initial value, we get what's called a particular solution. Okay. And I think you're good to go. Let me know if you need help with any practice problems. Good luck.